my background of being with the U.S. Department of Agriculture's Natural Resources Conservation Service. For the past 34 years, I've worked in federal government as a hydrologist and climate scientist, and the past 15 years as the director of the National Water and Climate Center, located in Portland, Oregon, and working throughout the Western U.S. The topic for today I will talk about is the program we oversee at the Water and Climate Center, which is the Snow Survey and Water Supply Forecasting Program. So to begin with, I would like to talk a little bit about the importance of snow for agriculture and for water supplies in the arid west of the US. People often ask why this snow survey is part of the Department of Agriculture and not a different department in the federal government. And the reason is both the history as well as the modern application of understanding water supplies as they relate to agriculture for irrigation. The Western US is a very dry part of the country, and irrigation for agriculture is a critical element. I've put up some different quotes, stories out of different sources, media sources, that kind of outline why this is so critical. The top one here talks about how between the three major mountain chains, the Rockies, the Sierra Nevada, and the Cascades in the Western US, the snow is really the vast majority of the annual water supply, the surface water supply. As the snow melts, it supplies water in the spring and summer for irrigation. And so most of the precipitation, most of that water supply comes in the form of snow in the higher mountains during the winter months. And really, as the first explorers that came into the Western US found that much of the West was really a desert, many of the basins very, very dry, if it wasn't for this water supply from the snowpack, then the agriculture would not be possible. And it's really important in agriculture because they use our water supply forecasts to plan how to approach their annual croppage. So what kind of plants to plant, what seeds to buy, when to plant, when to harvest, when to irrigate, really all depends on how much water they will have each year. And so that is really a critical element, is that we do the best we can to provide accurate forecasts of water supplies from this snow melt that's going to head out from the mountains to the valleys each year, so that they can plan for this ahead of time. And it's not just for agriculture, but really the water supply that comes from the snowpack really is, it impacts everybody in the Western US. Because if you think about it, all the water that they drink for municipalities and for food and et cetera, that they would use within each household really is tied into the snowpack and how much snow we get each year. So a lot of folks will be watching the weather, looking into the snowpack out of curiosity for skiing and other recreation, but really it comes down to just the survival in the Western US. It really does depend on the snowpack and the water supplied by it. To give you an idea of how this varies from summer to winter, the graph in the upper left shows Idaho, and it shows the July precipitation, so during the summer, and then the winter precipitation. And you can see that the vast majority of the precipitation happens as snow in the mountains during the winter months. So the summers could be very dry, very little precipitation during the time that the crops are growing. So really they do depend then on that amount of the snow that happens in the mountains that then supplies the stream flow into the spring and summer. The lower left side, the graph there shows that of the top 10 irrigation states in the US, 5 of those are in the West. 5 of those are part of the snow survey program that we do. So really, these states that really depend on irrigation ties closely into those mountain states where the snowpack provides that water supply for the irrigation. Now, in the upper right side, it shows the difference between rainfall and the water supplied through irrigation from the stream flow. The brown area, orangish area being the natural rainfall, and the bluish area being what is supplied for irrigation in the Imperial Valley of California, which is one of the most important agricultural areas of the US. And so you can see that without having that irrigation water supply from the stream flow, that a lot of that agriculture that is essential for our economy and for feeding our country really wouldn't happen. So it really depends on that snowpack and stream flow. And then the lower graphic, looking at the Colorado River, and the next presentation after this that we have in a few weeks, we'll talk more about the Colorado River itself, as did the earlier presentation a few weeks ago. But just to give you an idea here, in the lower Colorado River system, which is a very important system in the US, the lower Colorado provides water to 3 of the states, to Arizona, Nevada, and California. California getting out of the 7.5 million acre feet of water that comes out of the Colorado for the lower states, 4.4 million acre feet of that goes to California. And if you look at how it's distributed there in California, 3.85 million acre feet of that water goes for agriculture. So that's how critical the water supply is for agriculture. So we have an area of California that is a huge economic engine for our country, a huge source of food for our country, very dependent on the water supply of the Colorado River, and the Colorado River getting most of its water supply from the snowmelt. So a little bit about the history of this program. And again, as I started off by saying that people question maybe why this is part of the US Department of Agriculture, I'll give you a little bit of background on the program itself. It's actually been around for over 100 years. In 1906, there was a professor at the University of Nevada in Reno. He was actually a classics professor, not a scientist, not a hydrologist, who made the observation that the amount of stream flow, how much water is flowing in the spring and summers out of the mountains, is closely related to how much snow they got during the winter. And so he actually started looking at how could he quantify this? How could he measure the amount of snow and then maybe forecast or predict how much water would come from that each year? So he devised a system where he developed snow tubes where he would actually go up into the mountains at a couple of different sites and find the depth of the snow and make these measurements at different times during the winter to find how much snow is up there. And then he would weigh that snow that he sampled to find out how much water content is in the snow. As we all know, snow is less dense than the liquid water. And so you can actually calculate how much water is in the snow, what we call snow water equivalent, by weighing the tube and knowing the depth of the snowpack where the tube was sampled. You can come up with then a number for how much water equivalent is in the snowpack. And then he'd use that to compare to the stream flow in the spring and summer to see the relationship between the snowpack and the stream flow. So he developed this sampler, this way of doing that, and started providing water supply forecasts in 1909, 1910. So again, over 112 years ago that these were first being produced. And other states then, that type of methodology had expanded to other states, other areas in the West. And so each state started doing something very similar, where they would go out in the winter and measure the snowpack to make better estimates of how much water they could have in the spring and summer when the snow was melting. And like I say, these programs were sort of state by state in the early part of the 1900s. And then in 1939, the Soil Conservation Service picked this up as a national program. So they took the information from all the different states and made it into a program within the agency. And as it shows here, the Soil Conservation Service is the precursor, the earlier version of the Natural Resources Conservation Service, which we currently are. And so the program has been within my agency for a long time. And so it's something that is a mission critical part of what we do within Natural Resources Conservation Service. The information we provide, as I talked about, was important for agriculture, but there are many, many other users of our information. And in fact, if our website goes down, our website is 24, it's always real-time information 24/7. We have, through web services, we provide continual information, data on what the snowpack and snow conditions are throughout the Western US. And if our website goes down, believe me, the emails and phone calls start right away, because it is used for so many other purposes. As you can see here, international treaties. I mean, the rivers flow, the Columbia River flows out of Canada into the US. The Colorado River flows from the US into Mexico. So it has international implications of knowing how much water will be going down these rivers. Hydroelectric power is a main user of our data. The dam operations throughout the Western US for generating hydroelectric power and reservoirs for other purposes, water supplies and recreations, are really big users of this, because if they have an idea of how much water will be coming with the spring snow melt and spring and summer flows, they can then manage the reservoirs, how much water to retain, how much water to release. So these power companies are very tied in with the information that we provide and how they then manage their operations. Same with other reservoirs throughout the Western US. The US Army Corps of Engineers, the US Bureau of Reclamation manage a number of reservoirs for water supplies, and not just agriculture, but water supplies for municipalities, water supplies for recreation, water supplies for fish habitat, many different operational needs. And so they also use our information, and it's critical for their operations as well. And as I mentioned, many of the cities in the West, Seattle, Portland, Denver, et cetera, they manage their own water supplies. And so they use our data, again, to really know how much water they're going to have each year, and then how to manage that water. Other applications, the U.S. Forest Service uses it to look at things such as avalanche potential, fire management. You know, a wet year versus a dry year can have a big impact on fires in the Western US. And so they use this information for that. And then other agencies that provide water supply forecasts and information on flooding and drought and emergency management, such as the National Weather Service, also use the information. So although we're part of the Department of Agriculture, we really have a broad number of users of our information. And that's a really important piece, because it shows that the data that we collect and the forecasts we provide have utility across the whole Western US. So I'm going to talk about the networks themselves. And so this map, and again, the blue dots are what's really important here. The red dots are a soil moisture network that is national, but focusing on the Western US, where the blue dots are, the dark ones and the light ones. These are our data collection network, and I will talk about those. But you can see that it's very focused in the Western US. And if you were to overlay this on a map that shows the mountain ranges, you would see that the dots very closely follow where the mountains are, because again, that's where the snow is occurring during the winter and accumulating. We think of the mountain snowpack as sort of a natural reservoir, similar to the dam operations I just talked about. The fact is that the snow will accumulate throughout the winter, and so it actually holds the water as a reservoir. And then once the snow starts to melt, usually beginning in April and May, it's just like releasing water from a reservoir. And so we look at that as kind of this natural reservoir within the Western US. So the Snow Survey and the Water Supply Forecasting Program consists of a number of data collection sites. One type of site, and I'll talk about these in a little bit more detail, but one type of site is what we call SNOTEL. And these are automated sites. This is a picture of the one on the right there. These are sites that are throughout the Western mountains that collect information continually. So it's in real time. So it collects information and transmits that information on a variety of parameters related to the snow itself in the Western US. And again, these are automated, and they operate throughout the year. And we have a different version of that, a more abbreviated version of SNOTEL, so has less sensors that we call SNOLIGHT that we'll put in some areas as well where we don't need a full SNOTEL station. And then other sources of information, we have some hydromet stations, and then over 1,000 snow courses. These are the ones where, and again, I will talk about this in a little bit more detail, but these are where we go up into the mountains physically during the winter and actually make those snow measurements, very similar to what Dr. Church did back in 1906 when he went up in the mountains with the snow tubes and was measuring the snowpack. We continue to do that today at over 1,000 sites. And then what we do is we tie in then our snow measurements with the USGS has stream flow stations on rivers across the Western US. And so we tie this in with these stream flow stations to provide water supply forecast. And we publish these throughout the winter and provide this through web services. So anybody can access this information on the internet. Of course, being a government agency, everything we do is open to the public, and all the information is free to everybody to use. And then we, again, we also will provide then, besides these, besides doing monthly sort of our major water supply forecast, what we do each month, we also will give daily forecast trends. So we can say, is the snowpack increasing and decreasing over the course of the of each of the months. So in between each of the major measurements, we also have then these forecasts that tell us what the trends are. Our website, our web services, is probably the most used of the websites within Natural Resources Conservation Service, especially during the winter. We have so many people, not just those that deal with water supply, but there's also climate science researchers, universities, and their students, a wide variety of users that get in and access our information. And so, you know, we have almost 1 million customers that we reach generally through our web services. So as I mentioned, I want to talk a little bit about each of the stations. The first is SNOTEL, which is snow telemetry. And at a SNOTEL station, and you can see a picture of one there on the left, these are automated stations that we install in remote areas. Generally, these are in basins that are higher in the mountains, that the basins themselves generally are protected. You can see the trees around there, because the idea is you want an area where the snow can accumulate during the winter. And although these stations operate year-round, the critical part of this is that they're operating during the winter months and providing information to us in real time. So at a SNOTEL site, we measure a number of different parameters. As I mentioned, we measure the snow water content, and how we do that is, as you can see, there is what we call a snow pillow. It's a large bladder, almost like a waterbed, that has a pressure transducer in it. And so as the snow accumulates on top of this filled bladder, it increases the pressure by the weight of the snow. And from that, we can then calculate how much water content was in that snowpack itself. We also measure then precipitation. We have what we call storage type gauges, where they're just large towers that collect precip both as rain and snow throughout the winter. And again, collect that information, and it's part of what we continually collect and transmit. Temperature, the same. We look at air temperature at each of the sites. The snow depth. The snow depth is a measurement using a sonic sensor that over top of the snow pillow, you can see the one arm that sticks out. That measures then the depth of the snow itself. And so, again, we know the weight of the snow, we know the depth of the snow, we have an idea of how much water content is within that snow. We also measure relative humidity. At many of the sites, we'll look at wind speed and wind directions with an anemometer to, again, look at the conditions at the site. We also collect information on solar radiation and how this might impact the snowpack itself. And at most of our sites now, we've installed soil moisture and soil temperature probes. And these probes are at various depths, 5, 10, 20, 50, and 100 centimeters in depth. And we collect then what the soil moisture and the soil temperature is at these sites. This is important for a number of reasons. As you can imagine, during the winter, this often freezes, the soil moisture. But understanding the soil temperature and the soil moisture can have a huge impact on what's going to happen from the melt of the snowpack itself. If you think about it, if the soil is frozen and has a high moisture content, a lot of that snow melt will run off. If it's a very dry soil, that'll infiltrate, it'll soak it up almost like a sponge. And so the soil moisture and the soil temperature are important parameters that we've, just in the last 10 years, we've started installing these at all of our sites, and we're over half our sites have it now. So as I mentioned, we're a Western program, so the SNOTEL network has 896 SNOTEL sites and 42 SNOLIGHT sites in the Western US. We cover the 13 Western states, that includes Alaska. We don't include Hawaii, of course. They do have snow, but it's not a major source of their water supply, but in the arid West here it is. This map on the right shows you the location of these SNOTEL stations as compared to the basins. And so if you notice the basin boundaries, oftentimes that's where you'll see the red dots, as that is usually the basin boundaries are the highest elevation between two basins. And so that's typically where you would have your snow sites and your SNOTEL sites. We make measurements, as I mentioned, continuously. At each of these sites, we transmit the information every hour. So it's real time, but it's I guess what we would call near real time. It's not happening, it's not being transmitted instantaneously, but each hour as it collects the information, it transmits that packet of data to us. How it's transmitted, there's different ways. We had a system previously that we're phasing out called Meteor Burst. And Meteor Burst is a really interesting system where it would transmit the data as a radio signal and bounce it off of a band of dust, meteor dust, about 50 kilometers above the Earth's surface to stations that would then, it would bounce these waves to what we call master stations that would collect the information and then transmit it to us in Portland via the internet. We've transitioned over now to using more of a different type of telemetry. We typically use cell phones in the areas where we have cell coverage. We don't always have cell coverage in the mountains in the US. There's many what we call dead areas where cell coverage doesn't happen. And in those areas, we use then satellite information. There's systems such as Iridium, which is a satellite phone system, and there's the GOES system, which is a satellite system operated by the US that we will use as well for transmitting the information to our office in Portland. One of the reasons that we started going to this automated system and the SNOTEL system, and we started doing this in the late 1970s. As I mentioned, our snow program has been in operation since the very early 1900s, but in the late 1970s, early 1980s, we started installing SNOTEL sites across the West. And the reason is, well, there's two good reasons for this. One is that the information, as I mentioned, is in near real time. So it transmits data every hour Previously, when we would go up into the mountains to use the snow tubes and make those measurements, we do that once a month at the beginning of each month between January and June. So you only had those monthly measurements of snowpack, and a lot can happen in between the beginning and end of a month. There can be a lot of variations, a lot of changes in the snowpack. And so really having this additional information is critical. So in other words, you're getting 720 transmissions of snow information versus, each month versus that one measurement each month if we were to send people into the field. So a very treasure trove of data that wasn't always available to us before. And a second reason is because the SNOTEL sites measure more than just the snow water equivalent. These sites will measure temperature, precipitation, and all those other parameters I mentioned, relative humidity and wind speed, etc. All this information is important for understanding the physics of the snow, understanding what's happening with the snowpack itself. But one of the main reasons in my mind that we went this direction is as well as because of safety. I mean, there is hazardous conditions sending folks into the mountains in the winter when conditions can be variable, potential avalanches and other concerns that could put people in dangerous situations. So having these automated stations has improved the level of safety that we provide for our personnel, and that is an important factor. We still do the other measurements, but the automation of these sites has helped with the concerns with the safety factor. So if conditions aren't ideal for sending somebody in the field, you have an automated station, you're still getting the information and the data. So on a SNOTEL site, generally what we do is that these are installed usually in the summer, during the summer, what we call our maintenance season is when we install new SNOTEL sites, and also when we visit the sites during the summer to do summer maintenance at each of the sites. We'll go to each of the sites every summer, and oftentimes we will have to do different maintenance at the site to upkeep it. We'll change out sensors if they're going bad. We'll do regular maintenance on some of the other data collection sensors that we use there. So it's just important to visit the sites each summer, and we do that. And then during the winter, then we don't have to visit these sites. These sites then can provide the information to us during the winter. But as I mentioned, we also do the manual snow surveys as well. And you can see here the sampler tube has teeth around the bottom of it, and you literally drill down into the snow until you reach the ground. And then from that, because you can see there it's graduated up the side, you can see how deep the snowpack is at each of the sites. And then if you bring it up and you measure the weight of that, you can find with the depth of the snow and the weight of the snow, how much water content is in that snowpack at that site. So we do this at over 1,000 sites still. We go out once a month at the beginning of each month between January and June and collect this information. These snow courses, and many of these have been around for many, many decades, some of them going back into the 1920s and 30s. We go to the same location, and the measurements are taken during the winter, as I mentioned, and will provide additional information to the SNOTEL information. So this gives us information where we don't have SNOTEL sites. So it gives us better coverage across the Western US for the snow conditions. Generally, these are above 300 meters, or about 300 meters long. It's a transect that we measure from point A to point B. We'll make a number of measurements between 2 points, and we go to the same site each time. So it's not like there's variations. We go to the exact same sites, and we'll make generally between 5 and 10 measurements at intervals, evenly spaced intervals between those 2 points. So again, about 300 meters in distance. One of the difficulties here is getting to the sites in the winter, as I mentioned, the safety concern, but we use a number of different ways to access the sites in the winter. Snowmobiles, skis, snowshoes, some sites we can drive to if there's roads nearby. Other sites we can have to access with helicopters and fixed-wing planes. It really depends on the site, and some sites have better access, easier access than others. And some sites are in wilderness, which doesn't allow for us to use any kind of motorized transportation. So there we have to ski in or find other ways of getting, going in by foot to those sites. But we have to access these sites, I guess, say during the winter, and then that information is provided to us to help with our water supply forecasts. Just an idea then, as I mentioned, here are where the snow courses occur. As you can see, it's very similar to the snow-tell site map in basins where generally it's either with a snow-tell site, nearby a snow-tell site, or it's in different basins where we don't have a snow-tell site. And some photos, then you can see on the one photo, the helicopter is access to this one site in Utah, and then we see folks making measurements. So with that, just kind of to give you an idea of the data collection side of it, the sites oftentimes are very remote, very difficult to get to. In the lower right corner, you can see that is a snow-tell site, an aerial view that's in a very remote area. Often these are in wilderness areas and difficult to get to. So, and the sites during the winter can be very deep in snowpack. Oftentimes the snow can even exceed the height of our snow-tell stations in some areas. So the access to them is certainly one aspect of it. And for both doing the snow measurements in the winter as well as getting to the sites in the summer to do the maintenance. We have, most of our sites are, well, almost all of our sites are on US Forest Service lands or national park land. And in some places, we can't drive to those sites in the summer to do the summer maintenance, especially if they're in wilderness areas. They, again, don't allow motorized vehicles. So we will use things such as horse packing trips. We have a few sites that are in Yellowstone National Park that to access just one site to do the summer maintenance is a week-long process where we ride in on horseback with all of our equipment, and usually a large number of horses and mules carrying the equipment to do the maintenance, and then back out. It takes oftentimes 4 to 5 days. So all that time for just doing the maintenance on one single site. But there are very critical sites where these are located, and the information is important for our water supply forecasts. Now, if you go to our website at the National Water and Climate Center, we have a tool called the Interactive Map. And this is really a nice tool that we developed to allow folks to access information that they have a specific interest in. So you can go and really identify a point where you're looking for information and try to assess then the conditions there and the trends at that site. So for example, all the snow-tell sites, the snow courses, they're on this map, and you can go to a site, and if you put your cursor over one of those dots where we have a snow-tell site, it'll give you what we call metadata. It'll give you background information on the site itself, where it's located, its elevation. And then as you see in blue, the reports, there's different data reports you can pull up for a site. So it can give you, quickly can give you information of the site. For example, at this site, if I pulled up a graph, I can look at the trends in the snow water equivalent and the precipitation, both currently, as well as looking at the what we call the norms, the normals. So what would we do? What would we expect over the last 30 years? What we call the 30-year normal. So in this situation here, you can see the precip continues to go up, and the current precip in black is a little bit beneath what is the average, the 30-year normal. So we're right now at this point at when we're looking at this site, we're seeing that precip is below normal for what we would expect for this time of year. And the snowpack, the same. If we look at the snow water equivalent in red, that's the medium. That's what we would expect from the 30-year normals for the snowpack. And our snowpack in blue here is a little bit less than what we would expect this time of the year for the snowpack at this site. And you can see too and this graph is it kind of illustrates one thing as well, is that you can see the precipitation again in gray and the snowpack in red for the mediums for the 30-year averages, normals. These you see the snowpack drops off, and it's in April we see that decrease. Generally across the Western US, we've used the April 1st date as it's been pretty much our standard for what we consider to be the maximum amount of snowpack. So you think about the snow accumulating throughout the winter, and as a reservoir, just keeps accumulating. And then you get to April, and after April 1st is when the temperatures are such that the snow starts to melt. And we see a drop off in the snow here, the snowpack here. And that's kind of what we use throughout the Western US. And with climate change, we might have to adjust that as the snow melt, potentially could happen earlier and earlier. But as of now, we use April 1st as kind of our standard of what the maximum snowpack is before the snow melt begins. Okay, so with this interactive map, and there's a number of different tools, and I'll talk about those real briefly here. As you can see, this is the map, and this has point coverage for all the different snow-tell stations, both in Alaska and in the continental US. And the color will tell you then, and this is for each day, so this is updated daily. So it'll tell you in this case, February 23rd of 2021, you can see the different colors that relate to where we are on the snow water equivalent compared to the 30-year normal. So compared to average, are we below average? Are we above average? And for much of this area, the orange and red areas indicate that we are below average percent-wise versus what we would expect at this time of year. So it can tell us if we're having a poor year for snowpack or a very good year for snowpack. On the right side, you can see that there's ways that you can look at different types of information. So right now I'm looking at snow water equivalent, but if I clicked on the different parameters, soil moisture, soil temperature, the snow depth, or precipitation, for the same stations, I can find information and see where we're at compared to to average, compared to the 30-year medians, the normals for that day. And kind of give you just kind of a comparison here. So that was in 2021. So I looked at April 1st, and again, what we consider peak snowpack of this year, I'm sorry. And you can see, just as a comparison, you can see the colors on the map is very different. We're looking here, and much of the area throughout the further in the west, when you get to the Cascades and stuff, is well below normal for the snowpack. And then there's areas in the Rockies that are more aligned with normal. But generally, most of our sites on April 1st of this year were below normal for the snowpack for the year, which doesn't always bode well for the water supply. I mean, again, we're looking at water supply forecasting. So if this is April 1st, and that's what we're using as sort of our indicator of when the snow melt's about to begin, indicator of our maximum snowpack, this date is important because we can see then how much we can anticipate, how much we can forecast for water supplies for the coming year. And we can, besides looking at point data, we can look at it basin-wide. So with this interactive map, you can look at it not just from individual snow-tell sites, but you can look at it by basin. And so we can see here, looking at the basins, we can look at, and again, this is from February 23rd of 2021, we see that the very northern parts of the continental US were above normal, a very good year, in the northern part of the West for snowpack, whereas in the southern parts, you get down into Arizona and New Mexico and some of the southern states, the snowpack is much lower. You're looking at, well below normal on that snowpack. And that really is indicative of what we can expect as stream flow into the Colorado River. And I don't know how much you follow the news with the US, but the two major reservoirs on the Colorado River, Lake Mead and Lake Powell, are both at historic lows. The water supply, the extended drought in the Western US and the lack of stream flow related to the snowpack has impacted those reservoir systems. And so this graphic here is an indicator of why that's a problem. We're seeing below average snowpacks and snow water equivalent for those basins. And then April 1st of this year, again, kind of gives you just kind of a comparison. This year, it looks like the snowpack again, there's some basins that have right around normal, so between 90 to 109% in some parts of the West. But for much of the West, we were below normal again on snowpack. So the drought continues in the Western US. But looking at this from a basin perspective, Alaska, on the other side of it, by April 1st of this year, they were in very good situation for water supply with well above normal amounts of snow water equivalent. Other types of products that you can access through our website is, again, you can look at map graphics, not just through the interactive map, but we have map graphics that are updated daily that you can access. And the one on the left shows you each of the basins in the Western US with the percent of normal on the current snow water equivalent. So again, it puts a number on it. So you can look at it and say, okay, so some of these basins in green are above 100%. Many of the ones in yellow, brown, and red are well below normal. And of course, the blue ones are above average. So it gives you an indicator then, and again, this comes out daily. So each day you can really look at what's happening with the snowpack. If there's a basin that you live in, if there's a basin that supplies water to your reservoir, you can follow this on a daily basis and get an idea then of what's happening with the snowpack and what to anticipate for the conditions this summer. And knowing that conditions can change, one good storm coming in can change conditions greatly throughout parts of the West. The map on the right is just another way of looking at it. It's again the percent of snow water equivalent, the snow water equivalent compared to the percent of normal. And you can look at it just as point information, not basin information, but point information. So just different maps that are available that you can access and get information on a daily basis. Other information we can access through our webpage. One is, like the one on the left here, shows you an example of snow water equivalent for different basins in Colorado. So each of the states will provide information on the major basins in those states. And for a date, any day, you can pick and look at where we're at for that basin. So if it's not a map, but it's the same information, but it's provided as a graph, so that those that are trying to make plans for water supplies for the spring and summer can look at the graph and figure out then, okay, are we below normal? Are we above normal? What can we expect? And not just for the water supply itself, but that can have implications for concerns with things such as flooding. So if we were well above normal in the basin where you have a concern, then there's the potential then, if it's well above normal, that there's the potential for flooding. And so again, there might need to be preparations made because of that. So it gives you information that can be used for a variety of things. And then the one on the right is, again, looking at Colorado, but looking at one just basin, and then forecast points around that basin. It's providing what we are using as water supply forecasts. And so what we do is we give our forecasts as percents, what we consider to be what would be, and again, these are based on statistics. So what we expect to be the stream flow, if it would be a much above normal percent or below normal. This gives you an idea then of the percent of average, what we're predicting, what we're forecasting. And again, these are updated continuously, but we're forecasting for different basins. Some of these, if you look at these graphs, you can see that some of these bars are short. And we have a lot more confidence, so the forecast would be within a certain range, and other ones are very extended. A lot of that depends on the type of conditions at each of the basins. And what I mean by that is that in some basins, rain can dominate the type of precipitation if they're lower elevations. And that makes forecasting much more difficult if you have a rain-dominated basin versus one where we just have snow that accumulates over the winter and then melts in the spring. That's much more easier, much more accurate, a higher level of skill in the forecasting if you have conditions that are more stable. But when you have a rain-dominated system, then you have precip coming in and then flowing out continuously at different times during the winter, and that makes a forecast very difficult to do. So anyways, you can look at a graph like this and you can get an idea then of what the confidence levels are for each of the forecasts based on the size of the bar and the graph, and then where we're at compared to normal for those different basins. So talking just a little bit, I'm not going to get into a lot of detail, but talking just a little bit about the water supply forecasting. We take the data that we collect in the field, all that snow data from SNOTEL and snow courses, and we use that information then in hydrologic models to put out our water supply forecasts. And then these are used then for agricultural producers then to manage how they plan for the year for agriculture. So it's a two-step process. That's why the program is the Snow Survey and Water Supply Forecasting. The Snow Survey is the data collection side of it, and then the water supply forecasting is the tools that we provide the forecast from that data. Again, for those in the West to manage the water resources. There's a lot involved with the process. I mean, besides just the data collection, which I talked about at length. But the data as it comes in, then we have to ingest the data that comes in through telemetry and then the internet. We have to go through the data. And again, this is a continual process. Some of it is automated, some of it is manual, where we have people looking at the data, but there's also automated processes for us to do data quality, data control, quality control, looking at the data to oftentimes, if sensors are going bad or if there's outliers of data, you have to take that information and weed out the bad pieces of data to make sure that it doesn't skew your forecast, your information. So data quality and data overview is very important part of the process. And then we take that information and we put it into our model. We're currently using a model, and I'll talk about this in a second, but we're using a model called Viper. It's a statistical model, and we're developing new models, which will be, again, using information, but more of simulation models to really try to take into consideration not just statistics, but the conditions, the current conditions at the site. So as part of this, then we take the information, we put it into the models, we output our forecasts, and we provide that to our users via the internet. And that information, as some of the things I previously showed you, or you can get the information as data tables, you can get the information as maps, as graphs. There's a wide variety of ways that we provide the information, and it depends on the user. I mean, how they want to access that data, and then how they want to view it. So we provide that for those folks. So as obvious from this, the IT side of our operations. The IT support the maintenance of our databases, the access to our modeling, the flow of information both into our system and then out to our users. All this is heavily dependent on robust IT support. And so IT is a major piece of our process here. As I mentioned, we have one model that we're using currently is Viper. It's a visual interactive prediction and estimation routine. And this depends heavily on statistics. So what we do is the model itself brings in the data and it goes into an Excel spreadsheet. And then we visualize that. We look at it to see how those basins, how each of those sites, the SNOTEL sites, how they compare then to our 30-year normal. And the current 30-year normal is 1990 to 2020, that we're comparing it to that period of time to see if we're above or below. So we have an idea then of how we compare to previous years. And statistically, then we can then make an estimate of the water supply, looking at, again, the data from that period. One of the difficulties here, and there's statistic approach has been a very good approach for us. It seems to work very well, and our forecasts have what I would consider, again, it's basin by basin, but I would consider them to have a high level of skill and accuracy, considering all the different variables that can impact the spring snowmelt. That said, we're seeing changes. If you look at each of the 30-year normals, and again, we do this every 10 years, we'll shift the 30-year normal. And if you look at the 30-year normals over the last 100 years, we're seeing a shift in the 30-year normals because of climate change. We're seeing increased temperature. We're seeing changes in the precipitation patterns. And so a statistical approach, even with a 30-year period, oftentimes has its limitations because of variations, what we call non-stationarity, the idea that our conditions, our climate is changing in ways that aren't just stable over a longer historic period, but actually changing over time as we're seeing the impacts of the changing climate. So with that, the statistical approach oftentimes has some limitations to it. One of the things that we're developing right now is what we call M4, which is the multi-model machine learning meta system, which is a mouthful. It's a new system that we're working on currently. We've had a few publications on it. We haven't implemented it yet, but what it actually uses is artificial intelligence. It's machine learning that, again, it looks at conditions and looks at relationships. And so we'll actually, through machine learning, we'll actually improve the forecast. The more data that we have and the more comparisons we have with our snowpack to water supply forecast to actual stream flow, those types of things will improve over time. So this process is something we're working on now, and something that will be a way to do a water supply forecasting into the future. So as I mentioned, some of the future directions here is that we want to automate more of our manual snow courses. As I mentioned, there is a lot of benefits to having SNOTEL sites versus these manual snow courses where we send people in the field once a month during the winter. So if we can automate more of the manual snow course sites to SNOTEL sites, it'll provide information, better and more data for us in real time for our water supply forecasts. As I previously mentioned, we want to improve the models and our capacity to improve and put out more accurate water supply forecasts, bringing in other attributes to that, such as soil moisture and other ways of improving our forecasts. And we also want to look at developing more simulation modeling because, as I mentioned, the statistical modeling has its limitations. And so I think that if we develop simulation modeling. It would complement the statistical approach. You could do both, and then compare the two, and hopefully have a more accurate water supply forecast. One of the things that's happening in the Western US is there's now a lot of remote sensing. The Airborne Snow Observatory and others are collecting snow information every couple of weeks for selected basins. And they are using the information then to do water supply forecasts, very similar to what we do. So this is a thing of the future. I think that using satellite and fixed wing snow observations is one way then that you can have much better coverage than just having individual SNOTEL sites around the West. Even though, if you look at the map, there is a very dense concentration of SNOTEL sites in the Western US, there still is many areas, many basins where we don't have coverage. And oftentimes there's only one SNOTEL site per basin. Using this remote sensing is a way to get a better coverage, a better spatial coverage for the snowpack throughout the winter. But it doesn't replace, one doesn't replace the other. The idea here is that the remote sensing would still need to have the SNOTEL sites, the manual snow courses on the ground for calibration purposes. You know, they're making measurements and making estimations of the snow depth and the snow water equivalent. But again, without having those physical measurements to tie that to, the accuracy would be much less. And so it really is, there's a collaboration here to improve these water supply forecasts. And then, of course, we want to see improvements in the types of products we provide and how we deliver that information to folks. So improving our IT capacities. Ultimately, getting the information out to the users in a form and a methodology that they can access readily is really the critical piece here. And again, we have a wide variety of users. Getting the information out to those who really that we're here to serve, which is the agricultural community, in a way that helps them, is something that we are continually trying to improve on, and something that will always be an effort for us. And then just kind of to show you, because, and again, this happens within the US, but I think with any government, all efforts in the science field really comes through collaboration. And for us, we collaborate with a number of agencies, with not just the federal ones, but many state and universities as well. But within the federal government, we work closely with the Forest Service, the Corps of Engineers, Reclamation, and other federal agencies to provide information. We measure the snowpack, but others measure other sources of data. The U.S. Geological Survey measures stream flow. We work with each other, providing data and access to that information, that data, so that we can then, you know, again, produce the most accurate and usable forecast that we can. And we also, the information besides just water supply forecasting is critical for other efforts in the West, as I mentioned, fire control, drought assessment. There's a lot of users of our information. The U.S. Drought Monitor, which is an effort that puts out, assesses drought throughout the United States. Our snow information is one of the major pieces of information they use when they put out their weekly drought assessments. And then there's, of course, other committees and other groups of scientists we work with within the federal agencies. So we aren't isolated. We aren't a single agency with a single mission, but we are an agency with a mission that really transcends and intersects with much of the other efforts that other federal agencies do. And so having that communication, that collaboration is essential for providing the best amount of information and service to the public, to our country. For more information, you can go to our website here. This is the NRCS website, so you can get access. If you go here, you can get to the interactive map. You can go to all those different map products I showed. There's publications and information there that can potentially answer questions you might have. And of course, you could always, you know, contact. There's on those pages, there's contact links as well that you can contact individuals, groups, depends on the question you have, and hopefully work with folks to answer those questions.